Hello, if you're watching this video, you are reviewing for your Unit 7 test. Now, if you watched the previous video, we looked primarily or only at right triangles, or triangles with right angles in them, and we used SOHCAHTOA for those triangles. In this video, we're going to look only at non-right triangles. But before we get started, take note of the equation that you need to know for your Unit 7 test. I've added the area equation for triangle to the bottom there. But those are the equations that you need to know. They will not, once again, they will not be given to you on the test, so you need to know those for your test. Now, like I said, in this video we're going to focus only on non-right triangles. Now, one of the biggest questions I've gotten from you guys over this unit is, how do we know when to use law of sines and law of cosines? Now, here I have 4 triangles. 2 of the triangles we use law of sines, 2 of the triangles we use law of cosines. You can try on your own right now to figure out which one's which. So, hopefully you could figure out which one was law of sines, law of cosines. If you need more time, just pause your video. We'll go through it here in a second. But law of cosines, or sorry, law of sines. That's where I like to start with. In order to know when to use law of sines, you need to have an angle side pair, meaning you have a side and an angle that you know. Sorry, a side and the angle approximate that we know. So, for example, in this triangle, I know angle B is 35. I know this side is 8. That's my side angle pair. Right? See that? Side and the angle approximate, I know them both. So I'm going to use law of sines. Same thing here. Side, angle. I'm going to use law of sines. So these ones are my law of sines, meaning these two are my law of cosines. Now if we look at both of these, I do not have a side angle pair. I know, and I cannot find a side angle pair. So right here, I know this is 60. I don't know that side, not a side angle pair. I know this is 5, don't know that angle. I know this is 8, don't know that angle. So no side angle pairs. And then this one, I just know all 3 sides, so I don't have a side angle pair. So if you do not have or can't find a side angle pair, then that's when you have to use law of cosines. So these two are law of cosines. This is law of sines. Now, if you can't remember, the law of cosines is c squared equals a squared plus b squared minus 2ab cosine big C. So to determine or to find BC in this triangle, we're going to use the law of cosines. Now, I've told you in class that when you are using the law of cosines, it works best if you rename the side you want to find as little c. So if I want to find BC, that means I got to rename this side right here little c, making this a right here big C, which then turns this c into a, because we can't have 2 c's. Now from here, I can use the law of cosines to figure out what this side is. So c squared, my unknown, equals a squared, 5 squared, plus 8 squared, 60, oh, getting ahead of myself, plus 8 squared minus 2 times 5 times 8 times the cosine of 60. Now 5 squared is 25, 8 squared is 64, 2 times 5 times 8 is 80, cosine of 60 is 0.5, making this 40. Now, if you're trying that at home, great. Hopefully you got the same numbers I did. I know some of you are probably going to type this all in at once, then square at the end. That's fine too. You can do that. That is legal. Right? Now I like to do it in pieces as I'm going through right now. So we'll do c squared equals 25 plus 64, which is 89. Now 89 minus 40 is 49, which means c squared equals 49. So to solve for c, we need the square root of both sides. The square root of 49 is 7. That means this c right here is 7. Now, if they were asking me to solve this triangle, meaning I had to find all the sides and angles, once I know c is 7, from there I would use the law of sines to figure out my other angles, because I think the law of sines is a little bit easier to use than the law of cosines. We could use sine of 60 over 7, and we can use that to find either angle B or angle A. And then once you find those angles, you can use angle sum theorem to finish out solving the triangle. Now for this next triangle, it's a little bit different because we're given all 3 sides. And I want to find angle B. Now just like in the last triangle, we rename what we want to find as C. So I'm going to rename this right here as C. If that's C, that makes 10 little c. That makes 20 little a. And now since I renamed my B as C, I'm going to change my C to B, making this 17 little b. So now to use the law of cosines, to solve for what was b, but I renamed it as c. We're going to do 10 squared equals 17 squared plus 21 squared minus 2 times 10. Oh, why it's important to look at your look at how you renamed it, because this is 10 is c, so c only goes here. So 2 times 17 times 21 times cosine big B. Now from here we can figure out what 10 squared, 17 squared, and 21 are. So we get 10 squared is 100. 17 squared and 21 squared, I'm going to use my calculator. When we're talking about calculators, make sure your calculators are in degrees when you're doing problems like this. Right? If your calculator is not in degrees, then your answers are going to be a little bit different than the ones I'm getting. So 17 squared is 289, 21 squared is 441, and then 2 times 17 times 21 is 714. Now from here, students often make the biggest mistake, and that mistake is when they go to combine their like terms, they'll combine the 289, the 441, and the 714 because they say those are all numbers. But what they forget is this cosine B, oops, should have named it cosine C. Sorry about that, guys. Because we renamed that as C. Man, long day today. Sorry, guys. So once again, this is C because I renamed it as C. But what they'll do is they'll forget to combine, or when they go to combine these, they'll combine the 714 as well because they say, oh, 714 cosine C. They'll forget that cosine C is a variable. So you gotta remember that this right here is like having a 714x. So we can't combine that with these. All right, so we're going to do 289 plus 441. And we get 730. So we have 100 equals 730 minus 714 times the cosine of C. So now from here I'm going to subtract 730 from both sides. So 100 minus 730 is 630. Negative, so you get negative 630 equals negative 714 times cosine C. Okay. Now from here we're going to divide both sides by negative 714 once again because it's like having negative 714x. I'm going to move over here because I'm running out of board space. So we have negative 630 divided by negative 714. We get 0.8823. So we're on to 0.882 equals the cosine of C. Now from here I need to get rid of my cosine C, so I take the inverse cosine on both sides. So inverse cosine this side, inverse cosine this side. So those cancel. And the inverse cosine of 0.882 is 28. 0.115, so we'll put 28.12 degrees. That's what my C is. Right. Now, this is where I made a mistake earlier. We renamed our C as B, so then I went back and I changed the what was B to C because we renamed it. But when I get 28.12, don't confuse yourself and think, oh, it's 28.12 is this number over here. All right, because remember we renamed it. The original name was C, but we renamed that as B. So the 28.12 is actually this angle right here, since that's one renamed as C. Now on a problem where I say, what's the measure of angle B, don't think you have to go find this one now. Okay, this was the original B. That's the angle I'm looking for. So your answer would be 28.12. Right. So don't forget what you originally named them. So that when you're renaming, don't scribble out the letters. Just put one line through them so you can still see what they were. Hopefully that makes sense. If you have any questions, please come see me during class again. Now these next two triangles, these are law of sines triangles. The reason why I know they're law of sines triangles is because we have angle side pairs, where we know the angle and the side across them. Now in this first triangle, we need to find C. C is this angle right here. All right. Now, if we look, we know 35 and we know 8. All right. That's my side angle pair. That's B and little b. All right. So if I look at the law of sines, which I've written up here in green, It's sine A over A equals sine B over B equals sine C over C. Now the sine B over B is the part I have to use because that's the angle side pair I have. Now I want to find big C, so that means I got to use big C over little c. So I can leave out the sine A over A. Whenever you're using law of sines, you just pick two of the three that you need to make the equation to find what you need to find. So I'm trying to find C, so we're going to do sine of 35 over 8 equals sine of C over 13. Okay. So we can calculate sine of 35, which is 0.57. 0.5735, so we'll call it 0.574 over 8 equals sine of C over 13. Now from here we can cross multiply. So we get 0.574 times 13 equals 8 times the sine of C. And now my goal is to find what C is. You can calculate this out and then divide by 8. I like to do all my calculations in one step. So I'm going to divide by 8. So my calculator, I'm going to put 0.574 times 13 divided by 8. We get 0.9327, so 0.933 equals sine C. Now I need to get rid of my sine, so I take the inverse sine of both sides. So these cancel, leaving this C, and the inverse sine of 0.933 is 68.907, so we can put 68.91 degrees equals C. Now, whenever I use law of sines, we don't rename any of our sides or angles. So that is what angle C is. Right there. Well, there's no one here to ask questions. So once again, if you have any questions on that one, please come see me during class, and we can talk about it then. Now this next one. Okay, we want to find BC. BC is this side right here. It's across from A. So really I'm trying to find little a. Now you might say, whoa, we have one side angle pair. We have 18 and 5, but we do not have this angle. And we don't have A. So you're probably thinking, well, there's going to be two unknowns. How can I solve for two unknowns? But we have to remember in all triangles, all the angles add up to 180. So we can find A because we know A will equal 180 minus 105 minus 18. 180 minus 105 minus 18 is 57. Meaning this angle right here is 57 degrees. So now I have a side angle pair and an angle and the side I want to find. So I can pick the parts of the law of sines I need to use. Right? So like before I did sine of B over B equals sine of C over C. Here I'm going to do sine of C over little c equals sine of A over little a. And you can just pick what parts you need. So do sine of 18 over 5 equals sine of 57 over little a. I like to calculate my sines first, so I don't forget to. Sine of 18 is 0.309. It's actually 0.309016, so around 0.309 over 5. Sine of 57 is 0.83867, so we're going to do 0.839 over a. Now I'm going to cross multiply, coolest mathematical operation ever. Gets rid of my fractions, equals 5 times 0.839. Okay, so cross multiplying, get rid of my fractions. Then you can calculate this and then divide by 3.309. Like I said, I really like to do all my calculations in one step. We get A equals 5 times 0.839 divided by 0.309. We get 13.576. So we can write 13.58. And that's what it is. All right, now, a couple other questions you might come across on your review is where they'll say a triangle has sides, and they'll give you 3 sides, and they'll say, is that triangle obtuse, acute, or right? and then they'll also ask you the area of that triangle. So, give me a moment here while I prepare the board for the next problem. Let's say we have a triangle of sides 16.3, 8.8, and 12.9. Okay, so we have a triangle with sides 16.3, 8.8, and 12.9. Okay. Now we want to know the area, so we're going to find the area. We're also going to tell if obtuse, acute, acute, or right. Now, if you remember, an angle is obtuse if the angle is bigger than 90. Okay? An angle is acute if it's less than 90, and an angle is right if it's equal to 90. So those are things to keep in mind as we go through this problem. Now, I'm actually going to start with the the second question first. So whenever they tell me the sides of a triangle, but they don't necessarily give me the picture, I'd say the best thing for you to do is to draw a picture. So I'm going to draw a picture of my triangle. Here's my triangle. Longest side is going to be 16.3, hypotenuse 12.9, and 8.8. Now, something we talk about a lot in classes is if I have a triangle, which angle is the biggest angle? Which side is across from the biggest angle? And in class, we talk about how the biggest side is always across from the biggest angle. Now, when we're worried about a triangle being obtuse, acute, or right, the only angle we're worried about is the biggest angle, right? If the biggest angle is obtuse, the rest of the triangle, then the other angles will both be acute, but the triangle will be classified as obtuse. If the biggest angle is acute, then the other two angles will also be acute, making the triangle acute. And if the biggest angle is right, then it's a right triangle. So we're only worried about the biggest angle here. So if I'm going to determine if this triangle is obtuse, acute, or right, I need to find the measure of the side across from the biggest angle. Now, this triangle has three sides, so we should probably use the law of cosines. Right? And remember, I told you when we were using law of cosines to name the angle you want to find C. So I'm going to call this angle C because it's across my biggest angle. And then I'm going to call, doesn't matter, I can call this one A and this one B, or vice versa. And I'm going to use the law of cosines to figure out C. Right? So, using the law of cosines to find C. This is big C, this is little c, this is little b, and this is little a. Right? So now in order to find this angle, we're going to do 16.3 squared equals 12.9 squared plus 8.8 squared minus 2 times 12.9 times 8.8 times cosine big C. Put it off it. So I'm going to calculate those. I'm going to calculate my squareds and kind of simplify this best I can. So 16.3 squared is 265.69. 12.9 squared is 166.41. 8.8 squared is 77.44. And then 2 times 12.9 times 8.8 is 227.04 cosine big C. Right. Now, once again, this is like having an X on it, so I can't combine this with the other two. Bugging you guys at home, bugging me. All right, so I can't combine the 227 with the rest of it because this is like having an X. These don't. So I'm going to combine all my like terms. So we're going to do 166.41 plus 77.44. 243.85 minus 227.04 cosine C equals 265.69. So now I'm going to subtract the 243.85 from both sides. We get 21.84. equals negative 227.04 cosine big C. So now I'm going to divide by negative 227.04. Get negative 0.09619, so I'll call it 2, equals cosine C. So I'm going to take the inverse cosine of both sides. You get 95.52 equals C. Now, we found angle C. The answer, or the question is this obtuse, acute, or right? So in order to have a complete answer, I need to state what this is. So once again, if our angle is bigger than 90, then that means it's obtuse. This angle is bigger than 90, making this triangle obtuse. Had this been less than 90, it would be acute. Had it equal 90, it would be right. So this is an obtuse triangle because this angle C, our biggest angle, is greater than 90. So a little hint for when you're doing a problem like this, don't worry about what angle A and angle B are because those aren't our biggest angles. Only worry about the biggest angle. So find the biggest angle using the law of cosines, and then you can classify the triangle. Now the first question was, what's the area of this triangle, right? Now, to find the area, knowing this angle is 95, I mean that's not going to really help me the way that I taught you guys in class. So in order to find the area of this triangle, okay, we're basically going to kind of forget what we just did, finding angle C, and we're actually going to use the law of cosines one more time to find the angle. So if they give me a triangle like this where I know all three sides, in order to find the area, we need to calculate the height of the triangle. Now, it doesn't matter where you draw the height. You could draw the height from this one down. You could draw the height from this vertex up. Now, I like to keep it contained in the triangle. So we're going to say, here's my height. So in order to find the area of this triangle, I need to know this angle. So like you said earlier, if I want to find an angle, call that angle C. Okay, so this is going to be C. This can be A and B, doesn't matter. And I'm going to use the law of cosines again to find this angle. Now it's going to be set up a little bit differently this time because now 12.9 is my C, 16.3 is my B, and 8.8 is my A. All right. Now I know we're using the same triangle, but what we did to determine what's obtuse, acute, or right is completely independent of the area. You don't have to do them both. All right. So I'm going to find what angle C is, and then I can go on to find my area because this will be the height of my triangle. All right. So angle C, to find angle C, we do 12.9 squared, that's my C, equals 16.3, oh, put 3 on top. 16.3 squared minus 8.8 squared, or plus 8.8, sorry, minus 2 times 16.3 times 8.8 times the cosine of big C. Okay. Now, 12.9 squared is 166.41. 16.3 squared is 265.69. 8.8 squared is 77.44. 2 times 163, or sorry, 16.3 times 8.8 is 286.88. So this number is different from last time. These numbers are kind of switched around. But like I said, this is completely independent of what we did on the previous problem. So now I'm going to combine my like terms. So I'm going to add those two together. I cannot add this one because it has a variable on it. So now I'm going to subtract 343.13 from both sides. I'm going to divide by negative 2. Divide by negative 286.88. .616 equals cosine C. So we'll take the inverse cosine on both sides again. And we end up with 51.97 equals C. Now I know this angle right here is 51.97 degrees. Now in order to figure out my height, we're going to use the right triangle created by just the left side of my triangle. If you look, just right here, this little triangle right here, I'm going to use that right triangle. We know it's right because I drew my height, so it's perpendicular to side B. So I'm going to use that to find what H is. Now in this triangle, the 8.8 is my hypotenuse, the H is my opposite side, so I'm going to use sine. All right, so in order to find my H, we're going to use sine of 51.97 equals H over 8.8. So sine of 51.97, so I don't like that 8.8, 8.8. So sine of 51.97 is 0.787, actually 0.7876, so 0.788 equals H over 8.8. So I'll multiply by 8.8. And we end up with 6.931, so we should say 6.93 equals H. Now once again, it's not my answer, that's the height of this triangle. And this H stands for height, not hypotenuse. As I said earlier, 8.8 is our hypotenuse. So that's my height of the triangle. Now I'm going to create a little bit of space. Erase this right here. Now if you remember, the area of the triangle is 1/2 base times height. So, sorry about that, you missed my 8. So the area of the triangle is 1/2 base times height. So this is our height, that's my base, because the height and the base are always perpendicular. Right? So in order to figure out the area of our triangle, we do 1/2 of our base, 16.3, times our height, 6.93. So 1/2 of 16.3 times 6.93. You can type it in your calculator, 0.5 times as well. We get 56.479, so we'll do 56.48. And that'd be units squared. So then there is our area of our triangle. So, like I said earlier, you don't need to determine if it's obtuse, acute, or right to find the area. And you don't need to find the area to determine if it's obtuse, acute, or right. But we just use the same triangle for both examples. Once again, if you have questions, please let me know.